Today we are going to learn how to find position, velocity, and acceleration using functions and graphs. But first off, you need to know how to derive, and you also need to know that the order of functions is as follows. First comes position, then velocity, and then acceleration. And you can go back and forth between these three. We're going to start off with an easy problem on position. The movement of a particle is defined by the function x of t equals 8t squared plus 10t plus 3. Find the position of the particle at time t equals 5. For this problem, you are already given a function that represents the position of the particle. Therefore, all you need to do is simply substitute a 5 for every t in the function. Once you do this, you get x of 5 equals 8 times 5 squared plus 10 times 5 plus 3. From here on, all you need to do is simplify until you get your final answer. After simplifying the first time, you get 8 times 25 plus 50 plus 3. When you simplify again, you get 200 plus 53. And if you simplify once more to get your final answer, you get 253. Now we're going to find position using a graph. Find the position at x equals 2 of the particle represented by the graph below. Like in the other problem, you're already given something that represents the position of a particle, but this time it's the graph. So all you need to do is simply look at the graph at the x-axis and find the number 2. And you follow it until you hit the function and find the point where that lies. As you can see, at x equals 2, the y is equal to 2 as well. Therefore, the position at x equals 2 is 3. Now let's try a problem on velocity. The function g of x equals 2x squared represents the velocity of a particle. Find the velocity at time x equals 2. Now there are two ways of solving for this problem. The first way is by using the function that you are already given. So the problem tells you that g of x equals 2x squared represents the velocity. Therefore, all you need to do is substitute a 2 into the function. So you get 2 times 2 squared. And you simplify that until you find your final answer, which is 8. The second way of doing this is by looking at the velocity graph. You are given the graph here, and you need to find the number 2 on the x-axis and follow it until you hit the function, and then look for the y. In this case, the y is 8, and like we said before, that's your final answer. Now we're going to try another problem on velocity. Find the particle's velocity at t equals 3 when its position is defined by x of t equals 5t plus 4. Remember when I said that the order of functions is position, then velocity, and then acceleration? Well, the reason you need to know how to derive is so that you can find one when you're given another. In this case, you're given position, and you need to find velocity. Since velocity comes after position, if you derive position, you get velocity. So for this problem, you're going to derive x of t plus 5t plus 4. Once you do so, you get 5. And to find the velocity at time t equals 3, you substitute for every t in the function. This time, you don't really have a t, so you get x of 3 equals 5. And that's your final answer. Your velocity at time t equals 3 is 5. Now we are going to find acceleration using a function. Find the acceleration at t equals 2 of a particle moving at 5t cubed plus 25t plus 2 meters per second. Like in the previous problem, you are given the position of the particle and not what is being asked. Now, since you're being asked for acceleration, you need to derive twice, because like I said before, it's position, then velocity, and then acceleration. So you derive the first time to get velocity. In this case, the velocity is 15t squared plus 25. Then you derive again to find acceleration. And this time, your acceleration is 30t. Now that you have the functions that represent the acceleration of the particle, you can substitute the number 2 to find the acceleration at t equals 2. Once you do this, you get a of 2 equals 30 times 2. And you simplify to get your final answer, which is 60 meters per second squared. Here is our second problem on acceleration, but this time it involves the graph. Using the velocity graph below, find the acceleration in meters per minute of a particle at x equals 20. As you can see, you are given the velocity graph, not the acceleration graph. That is why you cannot simply look at the graph and find your answer. Instead, you use the mean value theorem. The formula for the mean value theorem is f times c equals f of b minus f of a all over b minus a. Now the reason you can use the mean value theorem is because f times c can also be the velocity derived. And as you know, the velocity derived is the acceleration. So to solve this problem, you need to find every piece of the equation so that you can substitute. But you need to make sure that your c falls in between between the a and the b. In this case, you can use a equals 15, c equals 30, and c, of course, has to be 20. And your f of a, or f of 15 equals 60, and your f of 30 equals 0. Now that you have all the pieces, you can substitute into the formula to find the answer. F times 20 equals 0 minus 60 all over 30 minus 60. From here on, you simplify till you find your final answer. Negative 60 over 15. If you simplify once more, you get negative 4. And so your answer is a is the acceleration at x equals 20 equals negative 4 meters per minute squared. Now we are going to learn how to find other things using functions that represent position, velocity, and acceleration. A particle's movement along the x-axis is defined by x of t equals 3t squared minus 10t plus 4. Now there are 3 parts to this problem. Let's start with the first part. To find where the particle changes direction, you need to find the velocity function. You can do this by deriving the function that represents the position of the particle. So in this case, once you derive the position, you get 16 minus 10. And this is the velocity. Once you have found your velocity, you set it equal to 0. 6t minus 10 equals 0. After doing so, you solve for t. Your answer turns out to be 10 over 6, which can be simplified to 5 over 3. And that is your answer. The particle changes direction at t equals 5 over 3. To find where the speed of the particle increases or decreases, you need to find where the particle changes direction. That we already did in the previous problem, and we established that the particle changes direction at t equals 5 over 3. Since we already have this, you can simply place it on a number line. And you can substitute any number that is not 5 over 3 into the velocity function. so that you can figure out whether it would be negative or positive on the left or the right side of the function. As you can see, on the left side of the velocity function, you get negative numbers, while on the right side, you get positive numbers. This means that between negative infinity and 5/3, the speed of the particle is decreasing. And on the right side, from 5/3 to positive infinity, the speed is increasing. Now let's try the third part. To find whether the velocity increases or decreases, you need to find the acceleration first. So first, since we're given the position, we find velocity. As we have said before, the velocity is 6t minus 10. Now to find acceleration, you derive again, and your answer is 6. Now, you can substitute into the acceleration equation or function, and you get a2 equals 6. Now, since your answer is positive, that means that the particle's velocity is increasing at time t equals 2. So these are just a few examples of what you can find using graphs, functions, and their derivatives. Thanks for watching.